Another class of important signals are analog signals and digital signals. Nowadays we are talking a lot about digital technology. The entire analog technology has been moved to digital technology, and the world around us is digital. So it is very important to understand the difference between analog signals and digital signals.
Analog signal and digital signal. We have just studied about the continuous time signal. Another name for the continuous time signal is nothing but analog signal. They got the name from the earlier use of this kind of electrical signals for representing the physical phenomena. They were using some kind of sensors. To get the values of the physical phenomena and represent that values as a voltage or current. So the sensors will show voltage or current, right? So in that time, so that voltage or current was analogous to the variation in the physical phenomena. So that's why they got the name analog signal. Here we can see that we have already seen that the x-axis can take any values. So the time axis is continuum. Similarly, the y-axis is also a continuum in the case of analog signal. What is meant by that? So these voltage values can take any values. For example, it can take 0.652314. It can take any values like that. There is no restriction in the amplitude values which this signal can take. Any signal which is already specified for the continuum of the time axis, and that also can take any value for amplitude, then such kind of signals are known as analog signals. This is the formal definition of an analog signal. If a continuous time signal x of t can take any amplitude value. So this word is very, very important. If a continuous time signal x of t can take any amplitude value in the continuous interval t1 and t2, then that continuous time signal x of t is called an analog signal. This is the most important word. It can take any amplitude value. It can be 0.8. It can be 0.873215 volt. This can be any value can take. It can take any values. Such signals are known as analog signals. So these kind of analog signals can be processed only using devices like resistor, capacitor, inductor, transistor, etc. Now, is there any other kind of continuous time signal? Yes. There is another kind of continuous time signal which is known as discrete value continuous time signal. See, actually this blue color represents our analog signal, and this red color represents our discrete value continuous time signal. So what is meant by discrete value continuous time signal? You can see that this red color discrete value continuous time signal cannot take any values in the amplitude axis. It cannot take any values in the amplitude axis. Rather, it can take only some particular values. For example, see, after 0 it is taking 0.5. If it has to go up, it can take only 0.6. It cannot take 0.55. It cannot take 0.55. No, 0.55 is not permitted. After 0.6, it can take only 0.7. It can then take only 0.6. So there is a restriction in the amplitude values. There is a restriction in the amplitude values. Okay, but still the time is continuous. You have to note this point very carefully, that the time is still continuous, but only restriction is in the case of the amplitude axis, the y-axis. It is specified in the continuum of time axis, but it can take only certain values in the y-axis, or it can take only certain amplitude values. Such signals are known as discrete value continuous time signal. Okay, so this is the continuous analog signal, that is continuous in time and continuous in voltage. It can take any value in the amplitude axis and it is defined in the continuum of the time axis. But this particular discrete value continuous time signal is defined in the continuum of the time axis, but it can take only certain restricted values in the amplitude axis. Now, why this kind of restriction is required, that I will explain in the next slide. So this is another kind of signal which we have already studied, that is discrete time signal. So here the signal is discretized in time axis, which we have already seen. See, we are taking only certain samples. These red dots are samples of the signals, but what about the values of the samples? Is the values of the samples, or is the amplitude values of the sample, is that restricted? No, it is not restricted. For example, this can be 0.64532150561. Okay, and this value can be 0.253231256. It can be any value. So any values it can take, even though it is discretized in the time axis. It is defined only at certain intervals of the time axis. Its value is not restricted. It can take any value. Now, what is the problem with this signal? Is this signal digital? Can we call this signal digital signal? No, it cannot be called digital signal. Why? What is the problem? There is a problem because if we want to take different values, we know that the computers or the digital electronic elements will take values only as binaries, right? So if the values are infinite, if the amplitude values, any amplitude values are taken, then it is very difficult to represent that in binary, because we need so many representation. We need representation for 0.8. We need representation for 0.811. We need representation for 0.83215. So many binary representations are required, which in turn also increase the storage. So there should be a restriction in the amplitude axis also. In the y-axis also there should be a restriction, because we cannot allow all the values. We can allow only certain values so that we can save the storage space in the computer, so that we can represent the signal in the computer. That leads to the next signal, which is known as the digital signal. So what is a digital signal? It is already discretized in the x-axis or time axis. That means it is specified at certain intervals of the time axis. It's not a time continuum. It's not a continuum of the time axis. It is specified only at certain intervals of the time axis. Also, it is restricted to some restricted amplitude values. It has some restricted amplitude values. For example, this signal, see this point, this actually it is somewhere around 0.55, right? But we cannot allow that because that is restricted. So it will be considered as 0.6. If you look at this point, actually it is 1.5, but 1.5 volt. Let us take, if it is volt, it is 1.5 volt. But unfortunately we cannot allow that because we have restricted it. So we will consider as just 2 volt. Okay, and this kind of restriction in the y-axis, in the amplitude axis, is known as, technically it is known as quantization. Okay, so you are familiar with the quantization. What is the quantization? For example, if your mark is 36.5, you will go to the teacher, please round off it. So that is quantization. So teacher will round off that mark to 37 marks. So that is quantization. If some values in between values are coming in the actual signal, see this blue color is the actual signal. This blue color is the actual analog signal. So we need to convert that into digital signal. At that time we cannot allow any voltage values. In the previous case of discrete time signal, we can take any values. See the exact values of the analog signal can be considered for the samples. It is allowed, but that is not allowed in the case of digital signal. We have to restrict the amplitude to certain values and we can take only that value. Such signals are known as digital signals. So what is the definition of a digital signal? So what is the important point about a digital signal? The digital signals are sampled in time. They are sampled in time and quantized in amplitude. This is the exact definition of a digital signal. We call a signal digital signal only if it is sampled in time and quantized in amplitude. So we do this process to save the storage space. Otherwise we cannot store such signals in the computers and we cannot process it. And these values, once these restricted values are assigned to the signal, actual signal, then we will encode these values. Into binary, and that values are sent to the computer for processing. For example, if 0. will have a code, 0.4 will have a code, 0.3 will have a code, again it is 0.3, here 0.2 will have a code. So these encoded binary values will be sent to the computer for the processing. Now let us see that formal definition of a digital signal. If a discrete time signal, see this is very important, the definition is starting with a discrete time signal. Already it is sampled. So this means that already the signal is sampled. If a discrete time signal x of n can take only a finite number of distinct amplitude values. So this is very important. It can take only finite number of distinct amplitude values in the time interval n1 n2, then the discrete time signal x of n is called a digital signal. So this is the formal definition of a digital signal. If a discrete time signal x of n can take only a finite number of distinct amplitude values in the time interval n1 to n2, then the discrete time signal x of n is called a digital signal. I hope it is clear.
I hope you understand the concept of analog signals and digital signals.